All right, so let's go over the basics. So we have the TipTop One over here. It's a 4 HP module, and it's a sample player. So it's got this tiny little micro SD card over here, which you insert into this slot here. And basically it can play back monophonic wave files at up to 24-bit and 96 kilohertz. And it can play them pretty fast, so you can trigger like drum samples via some gate sequencer. So if we go over the buttons and knobs from the top to bottom, so up here we have the level, which is your basic volume. You have a trigger button here, which you can use to configure settings and also to manually play back a sound. Obviously over here we have the micro SD card, which comes pre-filled with some wave files, but you can also input your own, which we'll cover later. The yellow knob here is your file selector. So this is a rotary encoder, and you can basically toggle it to pick different sounds. Down here we have a pot for setting the pitch. And then we have three jacks here. One for CV control, so you can actually control either the sound that's being played or the pitch of the sound. Then we have a gate input, which is obviously for triggering the sound via a gate or a trigger, which is configurable. And then finally, we have the audio output. So just to get things started, let's just hear some samples. So the basic thing I'm going to do is just plug in the output directly into my line output here, which is going to my recorder. And then I can hit the button here to trigger a sound and change sounds with the knob here. And then I can use this knob to change the frequency. All right, so the next thing I'm going to do is show you a quick demo of the gate input. So over here on the left, I have a Korg SQ1, which is a little sequencer which has gate and CV outputs. So I'm going to patch the gate output of one of the CV channels into the gate input of the TipTop One, and then hit play. And as you can hear, the sound gets triggered, so I can change the sound. And then the other thing we can do is patch in a CV input here, which by default will control the frequency of the sound, and it'll be quantized. So in the manual, it says that this input isn't actually a 1 volt per octave, but one of the options is to have the sound quantized, which means that it doesn't have to follow the 1 volt per octave convention, because you'll automatically get tones in a Western scale. So I'm going to patch in the CV output here, and then the knobs that I have here will correspond to the pitch. So I mentioned that the CV input is quantized, but you can actually switch between 3 different modes of what the CV input will do. So you have a free mode, which means that the frequencies will be unquantized. You have quantized mode, which means that the frequencies will be quantized to musical scales, or not scales, but musical tones. And then finally, you have a CV mode for controlling the file. And this is different from the frequency ones, where in this case, the CV controls an offset of which sample will be played. So depending on what you pick on the yellow knob, for example, let's say you pick like the 10th sample, when you set the file mode for the CV, it'll pick samples from the 10th samples plus or minus some degree. So in order to change the CV mode, you hold the play button and you change the white knob here. And then you'll see the light inside the play button will change. So when the light is solid red, then you're in free pitch mode. When it's solid blue, you're in quantized pitch mode. And when it's flashing red, then it's a file selecting CV mode. So again, the way you change it is you hold the button and you change this knob. So you can see now it's solid red, solid blue, and then flashing red. So in order to confirm, you just let go the button at the given color. So this is quantized. And then I can change it to blue, which is free mode. then finally I can change it to flashing red. And then here we'll have which sample is played is being selected by the CV level. In addition to being able to change the CV mode, you can also set the gate/trigger mode. And you have 4 different modes here. So you have the trigger mode, which is the default one. So whenever you get a rising edge or just a trigger sound, the playback is triggered and it plays back until the sound fades out. The other mode is fade mode. So it's similar to the trigger mode, but it adds a little bit of crossfade between the samples to eliminate clicks. Then you have a gate mode, and in this case, the sound is only on as long as the gate is high. And finally, there's looping mode, and in this mode, the sample keeps looping until you change the file or until another trigger is hit. And you can toggle between these modes in a very similar fashion as we did for the CV mode. So again, you hold play, but this time you change the yellow knob here. And in this case, a solid red color means you're in trigger mode, solid blue means you're in gate mode, flashing red means you're in the fade mode, and flashing blue means you're in the loop mode. So by default, you're in trigger mode. So for example, I can change it. So let me quickly change back my CV to control pitch so that it's slightly easier to demo. And then to change the gate mode, again, you hold the button and you toggle this rotary, the yellow rotary encoder. So by default, the red means trigger mode. So that's what we had by default. I can change it to solid blue, which will put us into gate mode. And then when I hit trigger, and since on this sequencer I have a duty cycle control here, effectively I'm controlling the length of the gate. And as you can see, I can make the sound really short. And then we have fade mode, which is a little harder to hear, but that's when the light is flashing red. And finally you have loop mode, so this is flashing blue. And now when I hit a sound, it'll keep looping. So as you can see, the TipTop One comes with this little micro SD card, but it also comes with this handy adapter to convert it into a full SD card, so you can plug it into your computer and load your own sounds. So let's see how that works. All right, so I've just plugged in my SD card in here, and you can see the contents of the SD cards here on the right window. So it just mounts a drive on a Mac, and I'm assuming there's some similar way to access it on Windows. So here we have this config.txt file, which is just a standard text file. And basically this is a way for you to define, if you remember those 2 settings we set, the trigger type and the CV type, how I showed you, you can set them by holding the button on the actual module. Well, you can also set whatever the default settings are by updating this file here. That way you don't have to set these properties by hand every time. So as you can see, by default, the card ships with these bunch of different samples that have been pre-curated, but you can obviously add your own. So the way to do that is you basically need a monophonic wave file, and TipTop Audio recommends that you use Audacity to sort of clean up the file a little bit. So here we have Audacity, which is basically a free audio recording program you can just download online. If you just Google Audacity, it's probably going to be the first result or one of the first ones. So what they recommend doing is setting up what's called a chain here. So if you go to File, Edit Chains, you can click Add here, and we're going to add a chain called 1 for TipTop One. And what this allows you to do is specify different things, different ways to process the file, so you can batch process a bunch of files. So we just want to add 2 different things. So if you do insert here, it'll give you an option of all these things you can add and ways to process the file. So one thing we want to do is convert stereo to mono. So we're going to add that to the chain. And then the next thing we want to do is export a WAV file here. And that's basically it. So we just want these 2 things to happen. And I'm going to click OK. So the next thing we can do is create a little sample. So you don't have to use Audacity to actually make the samples. You can just import them later. So I'm just going to create a little audio file here. Test. So I'm going to trim it out a little bit because it's a little too, by just selecting and hitting delete. So I've gone ahead and saved my project into this folder here. And next thing I'm going to do, in order to export it, I'm just going to apply chain, and then we're going to pick the chain we created. I'm going to hit apply to current project. And what that does is it'll create this clean folder inside the folder or next to the folder where you saved your project. So if I go inside, here we have our WAV file. And I'm going to rename this to just one test without the underscore. Just want to make sure there is no difficulty in reading. The one has a few limitations on how you can name your files, and they're character limited. So you're safest to just go with plain alphanumeric characters with no spaces or anything, and make it as compact as possible. So I'm just going to copy this into here. That's about it. So now I'm just going to remove the SD card and load it into the module, and then we can play our little sound and see if it works. All right, so we're back here. So I've reinserted the SD card with the new contents. So if we hit play now, test, test, test. So you can hear that my test file is playing back properly.
Test, test, test,
Test.
Test, test, test.
And of course I can trigger it like we did before. Give it a gate signal.
Test, 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 test,
Test.
test, 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 test,
test, test, test,
And I can
test,
give it a
test,
CV
test,
signal.
test, 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 test,
test,
Test.
test, test,
test,
Test.
test,
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 Test.
test,
test, test.
So another thing I wanted to try is plugging in a single cycle waveform to see how the TipTop One will handle it. So in this case, I've downloaded a sine wave, and if you're not familiar with single cycle waveforms, it's basically what it sounds like. You just get one cycle of a wave, in this case a sine wave. And the idea is if we can get the sampler to loop this, you would get a constant pitch, so effectively you can turn it into a sine oscillator. And in this case, I've just exported this here. I called it a sine. And similarly, I'm just going to drag it in or copy paste it into my SD card. And then we can load it into the TipTop One and see how it reacts to that. And this is our single cycle wave. As you can hear, it doesn't actually, it's not very audible because it's only one cycle, which is really too small. So in order for us to have a looping sound, if you remember, we can change the trigger mode to looping. And that's by holding play and changing the yellow knob till we see a blue flashing light. So now we have a blue flashing light. I hit play now.
Test, 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 test.
And it keeps looping. So if I switch back to my single cycle wave, so now we can hear a continuous pitch. So again, I can feed my CV signal and hit play here. So now I can actually run this through my filter here. So we don't need the gate signal from here anymore because we're continuously looping, so there's nothing to actually trigger the sound. So more appropriately, the gate would function as something to control an envelope in this case. So let's create a quick little patch. So I'm running through my filter now, and we're going to go through the output. So I'm going to higher the gain here. And so we've effectively turned a 1 into an oscillator. So in order to complete sort of a basic oscillator, or sorry, a basic subtractive synth patch, I am going to complete the loop. So I have an envelope generator here and a VCA, so we can actually put everything together. So I'm going to use the gate from the sequencer to trigger my envelope here. I'm then going to feed the envelope output into the CV input of one of the channels of the micro VCA here. And then I'm going to feed my audio through the VCA. And finally, I'm going to route the output of the VCA into the line input. And now we have control over the envelope. And since the peaks acts as a dual envelope generator, I can actually feed the other gate signal into the second channel here. And then use that second envelope to control the cutoff frequency of the filter here. And that gives you a good example of how you can use a TipTop One as an oscillator effectively. But for now, let's get rid of this mess of cables here. All right, much better. So let's plug in the audio directly to the recorder here and see what it sounds like when you play a full track. Change the pitch. And of course, we can send it pitch values. Cases it works better if you have a more subtle pitch change. that's basically it. Hopefully that gives you a good overview of the kinds of things you can do with the TipTop One. So again, to recap, it's a 4 HP 24-bit 96K sample playback machine, and it loads wave files into this SD card. Unfortunately, you can't actually sample directly into the device from here. So it's meant more as a device for less of processing and sampling in real time, but more in loading your own sample library and then triggering it back here. So some use cases, you can use it as a sample-based drum machine, for example. So if you have multiple of these, you can assign different hits on each one and then trigger it with some kind of gate sequencer. You can also use it to play back entire songs like I just did here. So there doesn't appear to be a limit on the actual length of the songs you can put. And I believe it accepts up to 32 gig card, which is pretty huge. In this case, it comes shipped with a 8 gig card, and the sounds that are on there only take up like 50 megs. So you still have like 7 gigs free just with the one that came with it. And if you enjoy sort of lo-fi sounding waves like I do, then you can fill basically a huge amounts because those files only take up a little bit. So yeah, you can use it to play back entire songs. What's cool is the ability to CV control which file is being played. So this can give you really cool effects if you put, for example, like 6 different or 16 different snare drums, for example, or hi-hats. You can use the CV to sort of alternate between the samples to give you a more organic drum machine sound. So it's great for percussive stuff, but it also has CV control over pitch. So you can even use melodic things. So you can sample like a saxophone, put it in there, and then trigger a saxophone sound. And like I've shown, you can use a single cycle waveform and create an oscillator out of this thing. And the manual even suggests using it as an LFO, which I haven't tried yet, but effectively you can put a very slow waveform in there, set the loop mode, and then use the output to control other signals as basically use it as control voltage instead of audio. So maybe I still need to mess around a little bit with the single cycle thing, but I plugged in a sine wave, I set the loop mode, and it came out sounding more like a saw wave, if you heard. So I don't think the waves play back perfectly, and it's probably a fault of mine. Maybe I didn't process the sound enough. So let me know in the comments if you have better success with single cycle waveforms. I was expecting to get like a pure sine tone out of it, but there was a bit of a gap between the 2 cycles repeating, which resulted in a different kind of wave, which isn't to say it's bad. I mean, I don't think it was designed to do that anyways. And the sounds I got were pretty cool. So if you don't expect to get exactly the single cycle waveform you put in, then it's a pretty cool bonus feature. All right, so I'll leave it there for now. Hopefully you guys like this kind of stuff. Let me know. I'm fairly new to Eurorack, but I plan to get more modules and make more tutorials like this one. So be sure to subscribe if you want to stay up to date with stuff like this. And I'll see you guys in the next one.